Bismillahirrahmanirrahim. In this lecture we are going to discuss NFA, which is non-deterministic finite automata. A definition of NFA: non-deterministic finite automata is a collection of three things. The first is the finite set of state. It can have one initial state, intermediate state, and may a final state. May a final state means that it can have one final state, it can have many final state, it can have no final state. So the finite set of state, this definition is same in both deterministic finite automata, transaction graph, generalized transaction graph, and non-deterministic finite automata. The second is the finite set of input symbol. Possible input letter, it can be a comma b. Mostly we are taking example like for the set of input letters is a comma b. It can be any combination of a to z symbols and so on. And the third one is the finite set of transaction, change of state from one state to another. So this is simple definition which is almost same in all the deterministic, non-deterministic TG and GTG. The NFA lies between TG and NFA and DFA. Deterministic finite automata and transaction graph is the relaxed form of NFA. So the NFA lies between a transaction graph and DFA. DFA is the rules are more strict. NFA rules are DFA rules are more complex and strict rules. The TG rules are more relaxed, and NFA rules lies between the DFA and transaction graph. So in terms of construction rule, the second, what are the rules for NFA? So it can take a null transaction like transaction graph. The NFA can take null transaction like TG. Maybe no transaction for an input letter like TG. Maybe many transaction for an input like TG transaction. So these three rules are being taken from transaction graph. It can take transaction for null. It can a state can have no transaction for an input alphabet, or a state can have many transaction for an input alphabet. So these three are taken from transaction graph. The rest three are taken from DFA. May only one initial state like DFA, may or none final state like DFA, no transaction for a string or substring like DFA. DFA does not allow transaction for a string or substring. So it is the TG allow transaction for a string or substring, but DFA does not allow. So this rules is taken from DFA, that no transaction for a string or substring. This is in the first example of NFA, like a language starting with starting not string having double A with any combination of A plus B or any combination of A plus B or static at the beginning and at the end. DFA is a little bit like this, that a loop from A it goes to Q2, from B it goes to Q0 again, and from A it goes to Q3. A loop is on B. So if we are going to create NFA for this, so the basic thing in this language is it contain a string having double A. So we are going to take Q0. On A it goes to Q1. On another A, because it must have double A, on another A it goes to Q0, Q2, which is a final state. So we need to take any combination of A, B. So we are going to take a loop of A comma B, and any combination of A plus B whole static, we are going to take A comma B as simple. There is no transaction on Q1 on input letter B, but we do not need to take transaction for every letter on a state. So this is a simple method to create NFA. Another NFA can be converted to transaction graph. NFA is a transaction graph, a simple transaction graph, because transaction graph is more relaxed than NFA. So NFA will be a specialized form of transaction graph. So DFA can be converted to NFA. This is the DFA and this is the NFA. The language is that must end with B. So it means that it contain any combination of A, B at the beginning, but end must be on B. So NFA is simple. From Q0 we are going to take transaction for the basic rule. This is ending with B. So Q0 on B, it goes to Q1, which is the final state. Then if you are going to see the regular expression A plus B whole steric, so we are going to take a loop on A comma B. This is a simple method that you have to create NFA. This is another example. You have to take a look. The first one is the DFA, which is a more complex. The second one is the NFA. NFA, the language of word containing triple A or triple B. So first A, second A, third A, or first B, second B, third B, any combination of A plus B, any combination of A plus B. A simple method of NFA. NFA is simple than DFA. This is the assignment. The language starting and ending with the same letter, language having at least one A and B. You have to create NFA for these examples. Now every DFA, this is a quick question and answer. Every DFA can be constructed to be NFA. Every DFA can be constructed to a DFA. This is a rule. A DFA is the specialized form of NFA, but the converse is not true. NFA is not DFA, because NFA can, in NFA you can take empty transaction, but DFA you cannot take empty transaction, and so on. Every NFA can be constructed to a TG. Every NFA is the specialized form of transaction graph, but the converse is not true, because transaction graph allow transaction for a string or substring, but NFA cannot allow a string or substring transaction for a string or substring. That is why the converse is not true. Converting NFA to DFA. There are two methods to convert NFA to DFA. NFA is a transaction graph. NFA is converted to transaction graph. Then transaction graph is converted to a generalized transaction graph, in which is a simple regular expression. Then a regular expression is converted to DFA, deterministic finite automata. The second method is very easy, which we are going to discuss in this lecture, by transaction table. So by transaction table, suppose we have a NFA like this one, that a language containing double A and any combination of A plus A comma B at the beginning and any combination of A comma B at the end. So this is a simple NFA. So to convert this NFA into a DFA, we need to create a transaction table. So how to create a transaction table? For this we are going to discuss it in here. This is the same example: Q0, Q1, Q2. These are the states. These are the old states. Old state, and the new states will be created after it. So the first one is Q. The first state, if you are going to see, the first state is Q0. So Q0 is the first state, which will be our this is the initial state. Q0 is the initial state. So our new state will be q1. Q1 will be our new state for the, this is the NFA first state, this is the DFA first state. So on q0, on input letter A, it goes to q0, it goes to q0, it goes to q0. On input letter A, it q0, it remain in the q0 because it is a loop. So it is same as this new state, so it is equal to z1, it is equal to z1. It means it is into on q0, on input letter A and on input letter B, it goes to q0, it goes to q0 because B is also in a loop, comma, it also goes to q1 because B, there is a transaction on q0 and also a transaction on q to q1. So this is different from z1, so we are going to give it a new name, which is z2. This is our new state, this is our new state which contain two state of the old q0 and q1. Now we are going to take this new state, this is our new state. So the new state is q0 comma q1, which is z2. On q0, on input letter A, on q0, on input letter A, it remain in q0. On q0, on input letter A, it is remain in q0, comma. On q1, on input letter A, there is no transaction on A, so it is our old state, which is z1. q0 is equal to z1, that is our first initial state. Now goes to the reading B. On q0, there are on q0, on input letter A, it remains in q0, it remains in q0, sorry, on input letter q, on state q0, on input letter B, it remains in q0. Also on input letter B, it goes to q1, it goes to q1. Now on q1, on input letter A, there is no transaction. On q1, on input letter B, sorry, on q1, on input letter B, there is a transaction from q1 to q2. So this is a new state, this is the first state, this is the second state. There is no combination of q0, 1 and 2, so we are going to rename it q3. Now we are going to take this one, on q0, on input letter A, reading A, it remains in q0, it remains in q0. On input letter A, on q0, it remains in q0. Now goes to the q1. q1, on input letter A, there is no transaction. In q2, on input letter A, it remains in q2. So q0, q01, q01 to 3, there is no combination of q0 and q2, so this is our new state, which is z4. Now on q0, on input letter B, it remains in q0. it remains in Q0 on input letter B. Also on input letter B it goes to Q1. On input it goes to Q1. So coming to the Q1, on Q1 on input letter B it goes to Q2. Now at Q2 on input letter B it remains in Q2, which is also written like this, Q2. So Q0, Q1 and Q2 is the same state like Z3. This is Z3. Now this state is the new state, so we are taking this one. An input letter Q0 reading A, it remains in Q0. It remains in Q0. So from A it remains in Q0, comma, the next state is Q2. Q2 on input letter A, it remains in Q2. So Q0, Q2 is the same state like Z4. Now then on B, Q0 on input letter B, it remains in Q0. It remains in Q0, comma, on input letter B it goes to Q1, comma, it goes to Q1, it goes to Q1, and now on Q2, on input letter B it remains in Q2. So Q0, Q1, Q2 is the same state as Z3. So there is no new state. Z4, Z3 already discussed. So this is our transaction table for the NFA. Now we are going to create a DFA from this state. Z1 is our initial state. From Z1 reading A, it remain in Z1. So on A there will be a loop. From Z1 reading B, it goes to Z2. So we create a Z2. On reading B, it goes to Z2. Now coming to Z2. On Z2 reading A, it goes to Z1. On Z2 reading A, it goes to Z1. On in Z2 reading B, it goes to Z3. It goes to Z3. So when you are at Z3 reading A, it goes to Z4. Z3 reading A, it goes to Z4. On Z3 reading B, it is remain in Z3. So on B there will be a loop. So the last state is Z4. Z4 reading A goes to Z4. So on A there will be a loop. Z4 reading A remains as Z4. So it will be a loop on Z4. Z4 reading B, it goes to Z3. Z4 reading B goes to Z3. So this is our deterministic, which will be our final state, and then DFA it will be the, so Q0 is the initial state. So Q0 is the initial state. So our new state Z1 will be the initial state. Which of the state will be the final state? Though all those states which contain Q2 will be the final state. So there is no Q2, it is intermediate. There is Q2, so this state will be the final state. Also this state also contain the Q2. Q2 is the final state, so all those states which contain Q2 will be the final state. So Z3 and Z4 will be the final state. Z3 and Z4 will be the final state of the deterministic finite automata. So that is the method how to convert a DFA, how to convert NFA into a DFA. So this is your homework. Solve as many examples as you can. You need to convert this NFA into a DFA. Also, you need to convert this NFA into a DFA using a transaction table. Also, you have to try to convert NFA into a DFA using convert NFA into TG, then to regular expression. From regular expression you have to convert into a DFA. This is your home assignment for this lecture.